Okay, so we have a few problems to do. First one is solve this problem. Okay, so as I saw before, we first find the common denominator. Okay, it's pretty much the first thing you do anytime you see anything like this. Okay, unless it's a multiplication or division, in which case you don't really need the common denominator. Okay, so we find our common denominator. There it is. Now we multiply both sides by the common denominator. And after we've done a few of these, we figure out that, okay, well, you know, what that's doing is it's simplifying this thing to where we don't have any denominators, and it's an equation we can solve. Okay, well, what do? We write out, multiply both sides by the common denominator. That means we take this side, 1 over x minus 3, plus 5 over 2x plus 2. And we multiply it by that common denominator, which is x minus 3 times 2x plus 2. Okay, that's multiplying the left side by the common denominator. Here's the left side, it's multiplied by the common denominator. The right side is 6, and it's multiplied by the common denominator. So we're going to multiply x minus 3 times 2x plus 2 times 6. So we have the original left-hand side and the original right-hand side here and here. And they're multiplied by the common denominator, both of them. So that's a valid step. We haven't changed anything except the way the problem looks, okay? Now, what this does, we multiply this by the 1 over x plus 3. So the ones we're going to have x minus 3 times 2x plus 2. And we'll put that over 1 since we're multiplying it by a fraction. And that's multiplied by 1 over x minus 3 plus x minus 3 times 2x plus 2 over 1 times 5 over 2x plus 2. And that equals what we get when we multiply all this. Then we eventually have to multiply this, but let's go ahead and just squeeze it in there. Now things are going to simplify on the left-hand side. Things are going to simplify very considerably. Okay, we have an x minus 3 in the denominator here and an x minus 3 in the numerator. Now, when we multiply these, all this is going to be combined into the numerator, and the denominator is just going to be x minus 3. So x minus 3 is the denominator, and it's a factor of the numerator. It's one of the things you multiply together to get the numerator, so that x minus 3 cancel out. Similarly, 2x plus 2 will be your denominator when you multiply this out, and it's a factor of the numerator because it's one of the things that's multiplied to give you the numerator, so it cancels out. It divides out. You could rearrange this expression here to give you an x minus 3 over x minus 3 multiplied by the 2x plus 2, and the x minus 3's would divide out to give you 1 and so forth. Okay, that's the reason the cancellation works. Okay, so this gives us 2x plus 2 plus x minus 3 equals, well, now we multiply all this out, okay? And we multiply this out using the distributive law. And I'm not going to go through the details of the distributive law, but I expect you to do the details when you write it out. Don't just write out what you think. It's going to be x times 2x plus 2 minus 3 times 2x plus 2, and then you multiply the individual terms. And you're going to get 2x squared minus 4x minus 6 multiplied by 6. And well, that gives us 2x plus 2 added to x minus 3 gives us 3x minus 1. And let me just double check my multiplication here. Getting negative 6x and 4x. Okay, yeah. And multiplying 6 through here gives me 12x squared minus 24x minus 36. And now, this equation, we can bring it on up here. We get equals 3x minus 1. Okay. We get this equation. Now, we need to solve this equation. I'm not going to go through the details of the solution, but we got to recognize this as a quadratic equation. Really bad looking Q there, but okay, we'll live with it. Quadratic equation. Okay, now we have to put the quadratic equation into standard form so that we can solve it using the quadratic formula. We subtract the 3x from both sides and we get into 27x, and we add 1 to both sides, gives us plus 35 equals 0. We solve this using the quadratic formula. Now, I believe your discriminant is going to spot you here. You're going to have a negative under the radical, and you're not going to get a solution. But that's part of your solution. That's your solution. Okay, now you see that all this follows if we simply understand that we find the common denominator and multiply both sides by the common denominator. And then we have to do our steps, right? Well, we've been over all the details of how to do these steps. And algebra is moderately challenging here. One of the more challenging things you get to do with algebra. Okay? So there's the point. Now, the whole point of it is that look at what happens. You end up with an equation here that doesn't have any denominators. That's a whole lot simpler than what you have if you've got a bunch of denominators. Okay? Once you have this equation, then everything else just follows. You recognize that you have a quadratic equation and you solve it. Okay, that's an easy step if you remember how to solve a quadratic equation. And if you think to recognize that you have a quadratic equation. The key step here is multiply both sides by the common denominator. So just as a general rule, whenever you have a fraction, fractional expressions, rational expressions, that's a proper term. You find the common denominator, multiply by the common denominator, all your denominators cancel out. They go away. And what you end up with, even though it might look a little bit complicated, is way simpler than what you started with. Okay. Have a couple more problems. Okay, I asked them to, do this operation, 2x minus 4 over x plus 3 minus 3x plus 5 over x minus 2 equals what? Okay, well, how do we deal with this? This is two fractional expressions, and we've got to add them, actually got to subtract them. It involves finding a common denominator. Again, we find the common denominator. Is x plus 3 times x minus 2. All right. Now we want to write these expressions both with the common denominator. Okay, so we take our 2x minus 4 over x plus 3. And we have to get denominator x plus 3 times x minus 2, meaning we're going to have to multiply the denominator by x minus 2. Well, we can't just multiply the denominator by x minus 2. We have to also multiply the numerator by x minus 2, so that in fact we're just multiplying by 1. We're not changing the value of the fraction. Well, that's all it's going to take to get this term expressed in terms of the common denominator. We have this. Okay. Again, here we had x minus 2 in the denominator. We needed x plus 3. This is how we get it. So this is 2x minus 4 times x minus 2 over x plus 3 times x minus 2 minus 3x plus 5 times x plus 3 over x plus 3 times x minus 2. And of course, I wrote the x plus 3 and x minus 2 here in the same order I did here. Doesn't matter in which order you multiply the things. Okay. So now we see that the denominators are the same. And now we can simply combine the numerators. We'll have 2x minus 4 times x minus 2 minus 3x plus 5 times x minus 3. All over x plus 3 times x minus 2. Now we can continue this, but we've done that a number of times. So for right now, I'm going to leave it the way it is, but you continue this by expanding the square, or by expanding the two terms, and actually, yeah, maybe I better go ahead and do that. I think I need to see that. Okay, so we'll bring this up here. We have 2x minus 4 times x minus 2 minus the quantity 3x plus 5 times x minus 3, all divided by x plus 3 times x minus 2. I've just copied this down. then I multiply these out. 2x minus 4 times x minus 2 is, I'm debating. Yeah, I'm gonna write it out. 2x times x minus 2 minus 4 times x minus 2. Okay, using the distributive law. Minus, going to be 3x times x minus 3 plus 5 times x minus 3 all over x plus 3 times x minus 2. And then we have to multiply these out. 2x times x minus 2 is 2x squared minus 4x. Minus 4 times x is minus 4x. Minus 4 times minus 2 is plus 8. Then it's minus all this stuff. 3x times x is 3x squared. 3x times negative 3 is negative 9x. 5 times x is 5x. 5 times negative 3 is minus 15. All that over x plus 3 times x minus 2. And then we have, excuse me, 2x squared minus 8x plus 8 minus the quantity 3x squared minus 4x minus 15. And notice all I'm doing is I'm combining the x terms here to get the 8x and here to get the negative 4x. I'm not trying to do anything with this negative sign yet. I'm trying to do one step at a time. And then we have our denominator. And now we can write this as 2x squared minus 8x plus 8. Then the minus distributes through here. Minus 3x squared is negative 3x squared. Minus a negative 4x plus 4x. Minus a negative 15 is plus 15. Still over the same denominator. And now 2x squared minus 3x squared is negative x squared. Negative 8x plus 4x is negative 4x. 8 and 15 is 23. And now this doesn't factor, this won't simplify. Okay. So we're done. Unless we decide we want to multiply this out, we get x squared plus x minus 6 in the denominator. It might be desirable to do that. And it might be just as well to leave the denominator factor depending on what you're trying to achieve. Okay, so that's an addition or subtraction. Okay, that's what you do with addition or subtraction. Those are the details. You can start by finding the common denominator. You put everything over common denominator, and then you go ahead and just do the algebra to simplify it. Now, I don't guarantee, I haven't done a check here. I could have made a clerical mistake in doing all this, so check that out yourself. You might check, see what you get. Substitute x equals 2 in the original expression and see what you get. Substitute x equals 2 in the final expression and see what you get. If you get the same thing, chances are I've done it right. If you don't get the same thing, either you did the substitution wrong or I screwed up. Both are possible. Okay, now we've got this third problem where we're just doing a multiplication. So we have this problem to work out. And this one turns out to be the simplest. Because all we have to do to multiply these is multiply the numerator and multiply the denominators. So we have x plus 5 multiplied by x minus 3 divided by x minus 2 multiplied by 2x plus 4. Numerator times numerator, denominator times denominator. Now we go ahead and expand these expressions. We get x times x minus 3 plus 5 times x minus 3 divided by x times 2x plus 4 minus 2 times 2x plus 4, which gives us x squared minus 3x plus 5x minus 15 over 2x squared plus 4x minus 4x squared minus 8. And that's going to be then x squared plus 2x minus 15 divided by 2x squared. Oh, sorry. We have 2x. 2 times 2x is 4x. Negative 2 times 2x is negative 4x, not negative 4x squared. And we have 2x squared minus 8. And it just turns out here that we did our x terms, our 4x and negative 4x are equal and opposite, so they cancel each other out. They add up to 0, in other words. And not happy with the way that 8 looks. Okay, so we end up then with x squared plus 2x minus 15 over 2x squared minus 8. Turns out the 2x squared minus 8 factors. Two x squared minus 8, we can factor out the 2 and we get 2 times the quantity x squared minus 4. And that's one of our special products. So the denominator actually splits back into 2 times the quantity x minus 2 times x plus 2. But the numerator doesn't factor over the rational numbers. You're going to end up with a square root of 19 and among other things that try to factor this. So you're pretty much done. So the whole key is you multiply this out and then you check whether this simplifies. And we haven't talked in this class too much about how that simplifies. We'll talk about that more in pre-calculus, but I thought maybe we just go ahead and do that little step to make sure. Okay. Unfortunately, I didn't record what I was just doing. I'm gonna have to go over it a little more briefly. But go ahead and do what I ask you to do while I explain this again. So we want the graph of this function. Well, when we do a graph, first thing we ask are what are the intercepts? And then we focus. What's the x-intercept? What are the x-intercepts? What's the y-intercept? And we can do those in any order. I just said, okay, let's find the x-intercepts first. X-intercepts occur when y equals 0. This has to be a reflex. We have to understand this thoroughly. We can't sit around thinking, how do we get the x-intercept again? We let y equal 0. And what's that mean? We write the equation out with y equal to 0. Y is 0, so put a 0 here. We won't bother writing out the p of x. We'll just write out this expression here. And we can see that we can easily just kind of read off the solutions. If x equals 4, this is going to be 0, and 0 times whatever these give us is going to give us 0, so that's going to give us y equals 0. So x equals 4, or x equals -2, or x equals -6. All those numbers, and each of those numbers will give us 0 if we plug it in for x. So we know that the points 4, 0, -2, 0, and -6, 0 are on the graph. Well, I've already sketched those points on the graph. I've got the vertical dotted line, x equals 6, vertical dotted line, x equals -2, the vertical dotted line, x equals 4. And the points on the x-axis that correspond to those x values are going to be the points -6, 0, -2, 0, and 4, 0. The y-intercept, well, we find the y-intercept very easily. You let x equal 0, that means you just let y equal this expression, but you replace x by 0. And you get y equals -48. We don't try to keep the x and the y scales identical. The graphs usually are very, very steep and very elongated if you try to do that. So we use different scales for the x and the y axis. And I'll just arbitrarily put -48 here, just because it's on the graph, we can draw it. Now, the task is then to be, well, we got to have a curve that goes through all of these points. It also can't go through the x-axis anywhere else, and it can't go through the y-axis anywhere else. It can only go through the x-axis if you're going to use a value of x that makes this thing 0. And the only values that make this expression 0 are 4, which makes this 0, or -2, which will make this 0, or -6, which will make this 0. If one of these isn't 0, if none of these are 0, you're not going to get 0. You can't multiply 3 non-zero numbers together to get 0. So the graph can't go through the x-axis except at these 3 points. Okay, so let's see how you did with sketching a graph. Now there's more I can tell you. I haven't told you everything, so you're unlikely to get the correct graph unless you already know how. Okay, but at least we're going to start confronting the problem of trying to sketch the curve through the points that we know. Okay, now everybody came up with something very plausible. You know, it wasn't correct for this function, but we don't yet know how to do that, okay? So the whole task of how do we draw the curve through these points? I'm going to show you the way it actually looks, and then I'm going to explain why. And the curve actually is going to look something very much like this. Okay. Now, there's no reason why the curve couldn't. Okay, I'm just going to draw a couple of sketches here. There's no reason the curve couldn't do something like this. Okay. It hits the x-axis at all these points. I kind of missed it there, but you get the idea. That would follow the instruction, okay? Or what couldn't the curve look like this? No reason. But for this function, it won't look like either of these. Okay? The reason is if we multiply this out, now it's a bunch of steps using the distributive line. I'm not going to write that all out. If I multiply x plus 2 times x plus 6, I get x squared plus 8x plus 12. If I then multiply that by x minus 4, I'll have the x times x squared, which will give me x cubed. I'll have a minus 4x squared, but x times 8x is going to give me a plus 8x squared. So this is going to give me plus 4x squared. I'm going to have a 12x and a minus 32x. That's going to be minus 20x minus 48. Now, if you use the distributive law carefully and do everything step by step, and if I did it correctly in my head, and I kind of think I did, but check me, it's going to look like this. Okay. Now, if x is really big, p of x is close to just plain old x cubed. Because if x is really big, x cubed is so much bigger than x squared or x or any of the other terms that they're not going to matter very much. So it's close to the graph of x cubed. Now, what's the graph of x cubed look like? Well, we know what the graph of x cubed looks like. At least I hope we do, because we constructed it. And the graph of x cubed looks like this. Okay. Now, in between, oh, here we go. Now, in here, somewhere in the vicinity of the origin, X is not close to zero. Okay? X is not large. And maybe that's a better way to say it. And since I kind of messed up everything here, let me rewrite it. Okay, so I say X is not large when we're in here close to the origin. Okay, these aren't large X's. Okay. I'll say so P of X can wiggle, which is what you see it doing here. Okay, it gets to wiggle in here for X values close to zero, but when X gets large, and large might be a billion. Okay, when X gets really large, P of X is going to act like X cubed. All right. That's called the long run behavior. So that as we go down this way, the values act like X cubed, because what's X cubed do? It goes way down. It just takes off downward, right? It's really steep, really fast. So it does that over here and over here. So it's like X cubed, but with wiggles in the middle, and the wiggles are what we usually draw, because as soon as we get away from the zeros, it starts acting like at least something like X cubed. If we get just a little ways further from the origin than where the zeros are, it just takes off. Zero syndrome. And acts like this. Does that make sense? You might not understand why, but of course you have to understand what the graph of X cubed looks like. Okay? So that's the way it's going to be. Okay, so here's an example of a polynomial function in factored form. We want to find the intercepts. So leave the previous example up here. Might be helpful to you. See what you can do. Okay, well, then we have a little trouble getting started here. Let's find the y-intercepts. As most of you are trying to start with the x-intercepts, we're kind of imitating what we have over here. But the y-intercept is going to be a little bit easier. So let's see what you can find for the y-intercept. Okay, well, I'm going to move a little more quickly through this because we're nearly out of time. Y-intercept, you immediately write x equals 0. And if you got that far, that's very good. Well, what do you do now that you know x equals 0? Well, you got this expression with these x's in it. You write out the expression, but you replace x with 0. You get y equals 2 times 0 minus 6 times 0 plus 7 times 3 times 0 plus 12. That equals negative 6 times 7 times 12. And I put my parentheses in the wrong place and confused myself there. Well, now I got to multiply that out. That's negative 42 times 12 is negative 480, and 2 more is negative 504, I think. So now we can immediately have information that we can put on our graph. Y-intercept occurs, so y equals negative 504. Okay. X-intercepts. That occurs when y equals 0, so you're going to get 2x minus 6 equals 0 times x plus 7 times 3x plus 12 is going to have to equal 0. Since y equals this, if y equals 0, then all this has to equal 0. The only way this can equal 0 is 2x minus 6 equals 0, or x plus 7 equals 0, or 3x plus 12 equals 0. You can solve each of these equations for x. You get x equals 3, or x equals negative 7, or x equals negative 4. So now we can sketch. One for x equals 7, another one for x equals negative 7, another for x equals negative 4, and another for x equals 3. And there we have our x-intercepts. The graph is going to be very similar to the one we saw earlier. So we're going to do this sort of thing. There's our graph. It's going to be like x cubed this way. In this way, but you're going to have the wiggles in the middle. Okay, we'll go on with this next time.